Okay, so I'm just going to go ahead and get started with number 1. So number 1 says find the mass of oxygen gas. That lets me know right away that it is going to be piv inert. So I'm just going to go ahead and write PV equals nRT. So they want the mass of oxygen, and that's not exactly N, but it is close to N. That occupies this volume, so V equals 6.9 liters, and it has a pressure of 2.6 atm and a temperature of 266 Kelvin. So remembering that N, that is moles. Okay? So they want us to solve for grams, which I can't do directly, but what I can do is solve for moles and then convert to grams. So before I plug anything in, I'm going to check it against my R constant, liters, liters, atm, atm, Kelvin, Kelvin. So I'm good to plug everything in. So I've got pressure, so 2.6 times 6.9 equals N. R is always 0.0821, and temperature is in Kelvin, which is 266. So I'm going to solve for N. So I'm going to divide each side by 0.0821 and 266. These cancel. Now when you type this into your calculator, make sure you multiply on the top, hit divide 0.0821, and hit divide 266. So your calculator is going to spit out N equals 0.82148 moles of O2. N, once again, is moles. Okay. Now they didn't ask for moles, they actually wanted the mass, which is grams. So I'm just going to convert from moles of oxygen to grams of oxygen. Moles gets a 1, grams gets a 31.998, moles cancels out. Type that into my calculator, I get 26.2857. I look at sig figs. There are 2 sig figs here, 2 sig figs here, 2 sig figs here. So, oh, sorry, that's 3 sig figs. So the lower number is 2 sig figs. So the final answer is 26 grams of oxygen. Number 2, calculate the mass of a sample. Once again, this is going to be piv inert. PV equals nRT. Remember, N is moles. So they want the mass of the sample, and it's carbon dioxide, and it occupies this volume. So volume equals 436 milliliters. It has a pressure of 2,800 torr and a temperature of 45 degrees Celsius. So before I plug anything in, I'm going to check against my R constant. I need to be in liters. I'm in milliliters. So I'm going to go ahead and convert that to liters. Zoom in. So I want to get rid of milliliters. That goes on bottom. Liters goes on top. For every 1 liter, there are 10 to the 3 milliliters. And that gives me 0.436 liters. The next thing I'm going to do is look at my pressure. I'm torr here. I have to be in atm, so I'm going to convert it to atm. So for every 760 torr, there's 1 atm. And that gives me 3.6842 atm. And there's degrees Celsius here, and I see that I have to be in Kelvin. So I'm going to convert that to Kelvin. So all I need to do is add 273, and that gives me 318 Kelvin. So now all of my units match up with this R constant up here. I'm in liters, I'm in atm, and I'm in Kelvin. So now I can go ahead and plug everything into piv inert. So I'm just going to rewrite PV equals nRT. I'm going to plug and chug. Pressure is 3.6842. Volume is 0.436. I'm solving for N. R is 0.0821, and temperature is 318. So I'm going to solve for N. So I divide each side by 0.0821 and 318. Those cancel. So remember, when you type this into your calculator, you multiply the top, you hit divided by on the bottom, and then divided by again. So your calculator spits out N equals 0.061526. Now N is moles, and it's moles of CO2. And so I'm going to go ahead, and they asked for the mass of carbon dioxide. So I'm going to convert this to grams. So for every 1 mole of CO2, there are 44.009 grams of CO2. Type that into my calculator, and it spits out 2.707. Based on the 2800, that's 2 sig figs. That guy's 3 sig figs. Use the Kelvin, 3 sig figs. So the lower number of sig figs is 2. So I get 2.7 grams of carbon dioxide for my answer. Number 3. So I see the word initial. That is my hint, my first hint, that it's P1V1 over T1 equals P2V2 over T2. So when this many liters of a gas, so that's volume, that's V1, 5.32 liters of a gas initially at STP. So these right here are my ones. So its standard temperature is my T1, that's 0 degrees Celsius, and standard pressure is my P1. And P1 is 1.0 atm. And then here are my 2's. Increase to a temperature of 104 degrees Celsius, that's T2. A pressure of 1.7 atm. And they want the new volume, which is V2. So I'm going to plug this all into P1, V1. So pressure is 1.0. Volume is 5.32. Oh. All of your temperatures, regardless of the equation, need to be in Kelvin. So I add 273 to this. That gives me 273 Kelvin. And I need to add 273 to this guy. And that gives me 377 Kelvin. So this is over 273 equals P2, 1.7 times V2, which is what I'm trying to solve for, all over T2, which is 377. So I'm going to cross multiply. So I've got 273 times 1.7 times V2 equals, cross multiply the other two, 1.0 times 5.32 times 377. Now that they're all on the same line, it's much easier to solve this guy. So I'm going to solve for V2. So I divide each side by 273 and 1.7. Remember, when you type this into your calculator, you're going to multiply the guys on top, hit divide on bottom, hit divide by the other guy. So your calculator is going to spit out V2 equals 4.32156. Go back to sig figs, 3 sig figs. Use the Kelvin temperature, 3 sig figs, 2 sig figs, 3 sig figs, 2 sig figs. 2 is the lower number. So the final answer is V2 equals 4.3. Now I plugged in liters for volume, so I'm going to spit out liters for volume. Number 4, calculate the pressure, so they want pressure, of a 37-gram sample of hydrogen, so that's close to N, so you've got 37 grams of hydrogen. It has this volume, 288 milliliters, and a temperature of 39 degrees Celsius. So remember that R equals 0.0821 liters times ATM all over moles times Kelvin. So this is your hint for your units. You can't be in grams, you have to be in moles. So I'm going to convert grams of hydrogen to moles of hydrogen. So 2.0158 grams of H2 for every 1 mole of H2. And that gives me 18.3549 moles of H2. I can't be in milliliters, I have to be in liters. So I'm going to convert milliliters, so 10 to the 3rd milliliters for every 1 liter. And that gives me 0.288 liters. And I can't be in degrees Celsius, I have to be in Kelvin. So I'm going to add 273, and that gives me 312 Kelvin. So now that my units match up, moles, moles, liters, liters, Kelvin, Kelvin, I can go ahead and I can plug it. So I've got Pivnert, PV equals nRT, and I'm going to plug and chug. They want pressure, they give me volume, they gave me moles, 18.3549. I know R is always 0.0821 and temperature was 312. So I want to solve for pressure. So I divide each side by 0.288. Those cancel. And I get pressure equals 1632.5. Now I need to worry about sig figs. So I look back at my problem. They gave me 2 sig figs, 3 sig figs, use the Kelvin, 3 sig figs. So 2 is the lower number of sig figs. So 2 sig figs. So pressure equals 1600 atmospheres, ATM. Because atmospheres is the unit of pressure in this R constant here. So that's why my final pressure is an ATM. So moving on to number 5. Okay, so number 5, there's one of these on the test. So whenever you see the balanced equation, it's your hint that you need to be specific with what compounds it is. Notice how I even underlined the compounds. So they want grams of water, so that's N. So they want grams of H2O. They give you a volume of C3H8, so volume is 7.54 liters of C3H8. I'm getting specific here. I'm not just writing my number and unit, I'm writing what compound it is. I know I need to do that when I'm given an equation. They give me temperature is 23.1 degrees Celsius, and they give me a pressure of 2.3 ATM. So this is Pivnert, so I need to be in Kelvin. I actually always need to be in Kelvin in this chapter. So I add 273, and I get 296.1 Kelvin. So I'm going to go ahead and plug everything into Pivnert. PV equals nRT. So pressure is 2.3. Volume is 7.54. Solving for N. R 0.0821. And temperature is 296.1. Sorry. There we go. So I'm going to solve for N. I divide each side by 0.0821 and 296.1. Those cancel, and my calculator spits out N equals 0.7133 moles. Okay, N is in moles, Now, I plugged in liters of C3H8 right there. That means I've solved for moles of C3H8. But I'm looking back, and they didn't want moles of C3H8. They wanted grams of water. So now I just use stoichiometry, the balanced equation, to make a little switcheroo. So I am given 7.33 moles of C3H8. I'm going to make a switcheroo from C3H8 to water. So I'm going to get rid of moles of C3H8 and go to moles of water. So for every 1 mole of C3H8, there's 4 moles of water. Moles of C3H8 cancel. Now that I'm at moles of water, I can go to grams of water. Moles of water go on bottom. Grams of water go on top. For every 1 mole of water, there's 18.0148 grams. Moles cancel. Type that into my calculator, and my calculator spits out 51.399. Now I need to worry about sig figs. So I look back. This guy has 3 sig figs. Use the Kelvin. 4 sig figs. 2 sig figs. 2 is the lower number of sig figs. So that gives me 51 grams of water. Number 6. Suppose I have 3.4 liters at this pressure, new container, another volume, and they want a new pressure. So that's my hint that this is P1 V1 over T1 equals P2 V2 over T2. They also didn't give me anything with grams or moles, so that's how I know that I don't need to worry about using Pivner. That's how I know it's this guy. So they give me a volume. My first volume is 3.4 liters. They give me a pressure as 5.22 ATM. They give me a new volume, which is 7,543 milliliters. So V2 equals 7,543 milliliters. What is the new pressure? So P2 equals, I don't know. So I'm looking, and there are just P's and V's. That means I can just cancel out the temperature part of this equation. Now, before I plug anything into the equation, I need to look at my units. Notice V1 is in liters, whereas V2 is in milliliters. They need to be in the same exact unit. So you can convert liters to milliliters, or you could convert milliliters to liters. So I'm going to go ahead and I'm going to convert milliliters to liters because that's easier for me. So for every 1 liter, there are 10 to the 3 milliliters, and that gives me 7.543 liters. So now that my units match up, I can plug and chug. So P1 is 5.22, V1 is 3.4, P2 is I don't know, and V2 in liters is 7.543. Solve for pressure 2. Divide by 7.543. Type that into your calculator, and your calculator is going to spit out P2 equals 2.3529. Now I need to worry about sig figs. So I look back at my problem. 2 sig figs, 3 sig figs, 4 sig figs. So the answer should have 4 sig figs. I am just kidding. The lower number, the answer should have 2 sig figs. So the 5 bumps the 3 up. So P2 equals 2.4. Now I plugged in ATM for pressure, so I'm going to spit out ATM for pressure. Last but not least, number 7. Calculate the initial volume. So they want V1 of a gas at STP. So this right here, these are my ones. That means T1 is standard temperature and P1 is standard pressure, which is 1.0 atm. It's placed in a new container at these conditions. So these guys here, these are my 2s. So P2 equals 5.7 atm. V2 equals 235 milliliters. And T2 equals 68 degrees Celsius. So before I plug things in, I need to check my units. They're both in atmospheres. We're good. Temperature always has to be in Kelvin. So I'm going to add 273, and that gives me 273 Kelvin. I'm going to add 273 to this guy, and that gives me 341 Kelvin. So now that everything's good to go, notice I'm in milliliters. That's okay, because we're not using Pivner. You can leave it in milliliters, or you could convert it to liters if you wanted. So I've got P1 V1 over T1 equals P2 V2 over T2. So now I'm going to plug in chug. P1 is 1.0. V1 is I don't know. T1 is 273 equals P2, which is 5.7. V2, which is 235. And T2, which is 341. So I'm going to cross multiply these. So 273 times 5.7 times 235 equals, cross multiply the other guy, that equals 1.0 times V1 times 341. So I want to solve for V1. So I divide each side by 1.0 and 341. And make sure you you multiply, and then hit divide and divide. And your calculator is going to spit out V1 equals 1072.3. And I need to worry about sig figs, so I look back. Use Kelvin, 3, 2 sig figs, 2 sig figs, 3 sig figs, use Kelvin, 3 sig figs. So the lower number is 2, so 2 sig figs. 7 bumps that up. So V1 equals 1100. Now I plugged in milliliters, so I'm going to spit out milliliters. Or if you plugged in liters, it'd be 1.1 liters. I'm not going to do number 8 and 9 for you, because you need to figure those out on your own. But I also posted the answer key, just the paper format, in the Chapter 13-14 folder. So good luck. If you have any questions, make sure you shoot me an email. Have a good evening.